Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, viewers and subscribers, as well as uh, students in calculus. Here is another video, and I hope that it will help you in your preparations for your calculus course. Find the domain and sketch the graph of the function. There are four here. So the first one is f of x equals 3. So it is a constant function, 3. So we can set any value of x. So therefore, for part A, the domain is the set R, or from negative infinity to positive infinity. And the graph is simply 3 units above the x-axis as shown in the figure. So this is the graph of f of x equals 3. So 1, 2, 3. This is the origin. So it is 3 units above the x-axis. So that's why its graph is f of x equals 3. And you can set any value of x from negative infinity to positive infinity. The value of the function is always 3. For part B, because this is x squared equal minus 6x, there's no restriction as to the value of x. So the domain is again from negative infinity to positive infinity. Now, for those who have experience about graphs of functions, graphs of algebraic curves, this is a parabola. Let's transform this to the standard form of a parabola. Let's denote y equals g of x. So the domain is negative infinity to positive infinity. So let g of x be y, and it is x squared minus 6x. To complete the square of the right side, we add 9, and 9 is the square of 1/2 of the coefficient of x. So 1/2 of negative 6 is negative 3, and if we square that, that's 9. So we add 9 to both sides of this equation. Y plus 9 equals x squared minus 6x plus 9, and therefore y plus 9 equals x minus 3 quantity square, or x minus 3 quantity square equals y minus quantity negative 9, and compare it with the standard form of equation of a parabola, which is x minus h quantity square equals plus minus latus rectum quantity y minus k. The sign of the right side is simply the opening of the parabola. So since there are two values of x, it means that the parabola is open upward, because the latus rectum is 1. So it is open upward. There are two values of x, so left and right. So that's why it is either open up or open down. But because the sign is positive, latus rectum is always positive, of course. So the sign in the right side is positive. It means that it is open upward. Likewise, if this is y minus k quantity square equals plus minus rx minus h, then if it is positive, it means that if this is y minus k, then it means that the parabola is open to the right. If it is negative, then it is open to the left. So here it is open upward, and the vertex is at 3 comma negative 9, and the latus rectum is 1 unit, always positive. So for those who are not familiar with this, you can also sketch the graph by point plotting as shown here. So I plot first the vertex, which is 3 comma negative 9, because from the original function, when x is 3 squared minus 6 times 3, it is negative 9. So 3 units per grid, so this is 3 comma negative 9. Then y is 0 when x is 3 and when x is 6. So when x is 0 rather, and when x is 6. So when x is 0, y is 0, it passes through here, so that's why the parabola is opened up. When x is 6, 6 squared minus 6 times 6, it is also 0 as shown. So let's plot. And when x is negative 3, for example, so this is 9, then this is minus 6 times negative 3, so 18, so 27. When x is 9, 9 squared minus 6 times 9, it's also 27, positive 27, which is above. So therefore, we just connect these 3 points with a smooth curve, and remember it is a parabola that is open upward as shown in the figure. So that's g of x equals x squared minus 6x. For part C, this is also a parabola. The radicand should be positive or 0, positive t minus 5 should be greater equal to 0. Therefore, obviously the domain would be 5 comma positive infinity, or 5 comma infinity. Then this is again a parabola, that is one branch of the parabola. To make it a function, it is open to the right, so we substitute admissible values of t, 5 to infinity, and we just plot f of t, if you're not familiar with that. But I will transform this into standard equation of parabola. I'll call this S, let f of t be S, and it is square root of t minus 5, so squaring both sides, S square equals t minus 5, then this is S minus 0 square, so to transform it into equation of parabola, equals latus rectum quantity t minus 5, so the latus rectum again is 1 unit, and the vertex is at 5, because this is the independent variable. This is 0 when t is 5 comma 0. So to sketch the graph, so vertex is at 5 comma 0 because this is supposedly imagined as y and t is x. So it is in this form, but we just change this to y. Minus k quantity square equals latus rectum x minus h. So that's why it is now open to the right this time. Vertex is at 5 comma 0 because the squared term should be here, y minus k quantity square, so y minus 0 or s minus 0 quantity square, then latus rectum t minus 5, so that's why t is 5, the horizontal axis, and s is 0. Then other points to be plotted would be when t is 6, s is 1. S cannot be plus minus 1 from the original equation. It is positive square root of t minus 5. And there should only be one root for s, or else its graph will be intercepted by a vertical line by 2 points. So that's the reason why it is a function. It is one branch of the parabola that is open to the right. So when t is 5, so the graduation here 2, 4, 6, so 5 is here between, so s is 0, f of t is 0, or s is 0 here. When x is 6, square root of 6 minus 1 is 1, so 1 here. When x is, to make it a whole number, 9, so that square root of 9 minus 5 is 4, square root of 4 is 2, so 6, 8, 9 is somewhere here, and 2 would be there. Then the next one is t is 14, so that square root of 14 minus 5 is square root of 9, which is 3. So it should be here because 8, 10, 12, 14, 14 is here. So t is 3, it should be here. So that's it. These 4 points are enough to sketch the graph of the parabola that is open to the right, as expected if you're familiar with the graph of parabola. But if not, you just assign points in the domain, then connect those points with smooth curve as shown. So that's the graph of f of t equals square root of t minus 5. Then finally, for part D, we have f of u equals 3u plus absolute value of u over u. Then there is denominator. The denominator cannot be 0, so the restriction here, u should not be equal to 0. And any value of u can be assigned positive or negative, except u is 0, which will make this function undefined. So 0 is a point, u equals 0 is a point of discontinuity. That's the only restriction for its domain. Therefore, the domain would be from negative infinity to 0, not including 0, then union with 0, open parenthesis, 0 to positive infinity. So meaning 0 is not included in this domain. Now, for negative infinity to 0, or for u equals negative in this interval, absolute value of a negative value is simply the negative of u, so that negative of negative is positive. Therefore, we can replace absolute value of u by negative u, and this function becomes f of u equals 3u minus u over u, which reduces to 2u over u, or simply 2, as long as u is not 0, as in this domain. So for instance, if u is negative 1, so this is 3 times negative 1, negative 3, then absolute value of negative 1 is positive 1. So negative 3u plus 1 is negative 2u over negative 1, which is positive 2. That's why it is 2. When u is negative 3, for example, this becomes negative 9, and absolute value of negative 3 is positive 3. So negative 9 plus 3 is negative 6, divided by negative 3 is positive 2. So that checks that f of u is equal to constant 2 for negative infinity to u. Now for 0 to positive infinity, absolute value of u is simply u because it is positive in this interval. So f of u becomes 3u plus u over u, or 4u over u, which is equal to 4. We can cancel u because u is not equal to 0 in this interval 0 to positive infinity. Remember, 0 is not included as part of the restriction here. So f of u equals 4, which is a constant. So therefore, the graph should look like this. From negative infinity to 0, but not including 0, it is 2. So 2 units above the u-axis, as shown. And it is an open dot here when u is 0. Then when u is from 0 to positive infinity, except 0, this is an open depth, and it is 4, so 4 units above the u-axis as shown, and it is constant. So that's the graph of f of u equals 3u plus minus absolute value of u or plus absolute value of u over u. So that's it for this video, and I hope that you were able to understand the explanations and the sketching of graphs especially, and the determination of the domain of the function.